In previous lessons, you learned how to count with binary and convert that into standard decimal numbers. But there is another numbering system that computers use for various functions named hexadecimal, or hex for short. Hex is used as a way to more easily notate very long binary values, such as IPv6 addresses and MAC addresses. Hex is a 16-value number system represented in only 2 digits. These digits are the numbers 0 through 9 and the letters A through F. Each digit represents a 4-bit binary value, so the 8-bit binary values that we've worked with in previous lessons are a combination of 2 of these digits. For example, 168 equals A8. Let's dig deeper into how I came up with these values in 5 simple steps. Number 1, convert to binary. In previous lessons, you've worked with converting decimal values, so this step should be somewhat familiar. Let's begin with starting with the value of 168, and then working through each of our bits to get our binary value. So, does 128 go into 68? Yes, so we're going to turn that bit on, and then we're going to do our math. 168 minus 128 gives us a remainder of 40. Does 64 go into 40? No, so we're going to turn that bit off and move on. Does 32 go into 40? Yes, so we're going to turn that bit on. We're going to do our math. 40 minus 32 gives us a remainder of 8. So does 16 go into 8? No, we're going to turn that bit off and move on. And then does 8 go into 8? Obviously, yes, it does. So we're going to turn that on. Confirm here, 8 minus 8 is going to give us a remainder of 0. So then from here, we can just zero out the remainder of our bits. So this is going to give us a binary representation of the decimal number 168 that is 10101000. 2. Split the binary. Next, since hex digits are only 4 bits long, we must split our 8-bit value in half, giving us 2 4-bit values to work with. This gives us 1010 and 1000. 3. Find the new values. Now that we have isolated out 4-bit values, we need to reconvert them back into decimal using just the right-hand side of our binary conversion chart that we've used previously. So you simply plug in those 4-bit values and then add up each of their bits. So here we have 8 plus 2, because these are the only on bits. So 8 plus 2 is going to give us 10. And then on the other side, 8 is our only bit turned on, which gives us an ending value just of 8. 4. Convert to hex digits. Since each 4-bit value can only be represented with a single digit, the values 10 through 15 have to be converted into letters. So that's going to give us 10 is A, 11 B, 12 C, 13 D, 14 E, and 15 F. We have 10, so that's going to convert to A. 5. Combine the hex digits. With all of the real work done, this last step is simply to combine the 2 digits, giving us a final hex value of A8. With these 5 easy steps, converting to binary, splitting the binary, finding the new values, converting to hex digits, and then combining the hex digits, you can take any decimal or binary value and convert it into hex.